Hello and welcome to today's session. Today we'll discuss on understanding linear regressions with Python. So five important applications are sales forecasting, demand forecasting, price prediction, target marketing, and weather forecasting. Linear regression plays an important role of how a dependent variable is forecasted with respect to an independent variable. So most of the dependent variables with respect to the applications mentioned above would be on the y-axis, which are predicting the sales, predicting the quantity, predicting the price, predicting the effectiveness of a marketing campaign, predicting tomorrow's weather. But to predict a dependent variable, we need to understand what are the different independent variables that are required to properly analyze. For this, we'll try to look at how this graph will be with respect to the axis. So if you look at the y-axis, it is usually the dependent variable. And the dependent variable can usually be given as an equation to predict a particular parameter. So predicting a parameter, we denote it as y. And the regression with respect to the dependent variable can be given by mx plus c, where m is the slope of the regression line, which is going to be fitting all the points that are plotted in the application. So if you take, for an example, if the x-axis is going to be the days and y-axis is going to be the demand. The demand can be found by analyzing the number of days and how each day behaves in a chronological order. C here denotes the y-intercept. For us, it will be on the origin, which is usually the line fitting crossing through the origin. Sometimes it may not be on the origin. So to analyze this particular topic, you will try to implement a small code. So as I already mentioned, y is equal to mx plus c, and m is the slope and c is the y-intercept. I mean, for us, it is in the origin. The intercept means where the line crosses the y-axis. Y here is the line, here is the fitting line. So in the code, we'll first bring all the necessary libraries. We'll bring a sample data. This data can be changed with respect to how the application is. And we'll bring a model, which is the linear regression model, which we have been discussing until now. And we'll fix a model through which the line fitting through those different coordinates will pass through. from which we'll predict a new line which will cross after 6 and 7, if on the y-axis, if it is the number of days for an example, from which we'll do a prediction using model predict. And finally, we'll try to plot the graph, taking into account all the data and the model. So when we run this program, we'll get a graph as shown below. So this graph will give you the plot scatter in blue, which are the coordinates of different days and demand. And red line is the predicted forecast for the remaining 2 days. I mean, this is the future. These are the past values. So the past values for the days for different demands is as shown above. So this graph gives us a very important idea of how linear regression gives you a prediction of the future value. But an important thing to be considered is this line, when you extend it, will not exactly fall on the point. So there are some deviations. These deviations are called error. So to evaluate a model, an important benchmark is mean square error. So mean square error gives you an idea of how the demand forecast plays an important role with respect to the days, and it need not be the same throughout the month or week or an year. So it keeps changing. So if we can find the mean square error, we can easily understand how this data is being scattered and forecast the future demand accordingly. So for which we'll run a program by bringing the model predict and using the y, which is the forecast from the prediction string. So when we run the program, which is based on this particular formula, which is taking different values of the actual coordinates and what will be the forecast. So if we can imagine the actual value to be the coordinates will not fall exactly as the forecasted value. As you can see, there will be an error. So whenever we are going to subtract the actual minus forecast, it gives you the error with respect to the fitting of the line. So when we run this program, we'll get a value of approximately 47.9%. So that is the amount of error that the scattered value is forecasting with respect to the future demand. So there is a probability that there will be 50% chance of approximately 50% chance of the demand that is forecasted. Thank you.